Hello everyone. In the previous video, we calculated crude death rate. In this video, I will show you how to calculate age-specific death rates and standardized death ratio. We are going to use the same example as the one used in calculating crude death rate. The study was conducted by Christie, to examine deaths by coronary heart disease between officers versus other ranks in the British Army in a period of 5 years. This table shows us the data collected from the study. In the last video, we calculated crude death rate, also called crude mortality rate, for both military officers and other military ranks. Crude death rate for other ranks was 15.6 per 100,000 per year, and for military officers was 49.1 per 100,000 per year. Clearly, crude death rate was higher for military officers than other ranks, but can we conclude that military officers have a great risk of coronary heart disease death than other ranks? If we look back at the table, military officers seem to be older than other ranks in general. And the older a person is, the more likely they are vulnerable to death by coronary heart disease. Therefore, we should have a look at age-specific death rates. As you can see in the table, 49.1 is the crude death rate per year by coronary heart disease for military officers, and 15.6 is for other military ranks. We calculated these crude death rates in the previous video. Age-specific death rate is calculated the same way as we calculate crude death rate. However, we do this calculation for each age group instead of the total population. As an example, let's calculate death rate for military officers in the age group of 40 to 44. There were 6 deaths observed in 5 years, and the number of officers aged 40 to 44 was 3,000. Therefore, the death rate per 5 years in this age group was 6 over 3,000 equals 0.002 death per 5 years. This equals 200 deaths per 100,000 officer per 5 years. For death rate per year, we divide 200 by 5, which is equal 40 deaths per year. Repeat the calculation for each age group, we will have age-specific death rates. Now if we look at age-specific death rates, we can see that the rates are lower for officers compared to other ranks within each age groups. The only exception is among people aged 50 to 54. This could be due to the small sample size making the rate unreliable. Using age-specific death rates, our conclusion should be that military officers had lower risk of death by coronary heart disease compared to other ranks. Now, looking back at the table, there is information about coronary heart disease death rates in the UK general population. With this information available, we can use it to calculate standardized mortality ratio. Standardized mortality ratio is calculated by dividing the total number of observed deaths by the total number of expected deaths. The total number of observed deaths is the number of actual deaths we observed in the study, which is 41 military officers and 108 other ranks. The number of expected deaths is calculated using the UK general death rates and the population of military officer and other ranks. As you can see, a new table has been created that includes only information needed to calculate expected deaths. As an example, I will calculate expected deaths for military officers aged 35 to 39. As the UK general death rate in this age group is 33.5 per 100,000 per year, we multiply this with the number of officers in this age group, which is 2.7 in a unit of 1,000. This equals 0.9045 deaths per year. However, as our observed deaths are per 5 years, we need to multiply 0.9045 with 5. This gives us 4.52 expected deaths per 5 years. Repeat the calculation for military officers in other age groups, then add all the deaths up. We have the total number of expected deaths is 75.73 per 5 years. Do the same for other ranks. we have the total number of expected deaths is 72.92. Now, using the previous formula, we can calculate standardized mortality ratio for military officers and other ranks. For military officers, standardized mortality ratio is 0.54, which means that the number of deaths among military officers is about a half less than expected in the general population. For other ranks, it is 1.48, which means that the number of deaths among other ranks is higher than expected in the general population. This result shows that using crude death rates in comparison may lead to an accurate conclusion. Thank you for watching and see you.